Hi there, welcome to the second tutorial on Math Olympiad training. Thanks for taking time to watch this video. Hope you enjoyed the first one. The main objective of this video tutorial is to help you understand how to solve Math Olympiad questions more easily. If you are unclear with anything in this video, feel free to ask in the comment section. Remember to click the like button and share this video with anyone whom you think will benefit from it. Okay, let's start. In this tutorial, we will cover how you can solve problems using algebra. For those that learn how to draw models and use models to solve math problems, you can use that as well. But algebra will definitely enable you to solve complex problems faster. Some examples in this video are taken from this book titled Math Olympiad, Unleash the Math Olympian in You, Advanced Level by Terry Chiu. The link for this book can be found in the video description below. In this book, chapter 2 is called Comparison and Replacement. However, I think solving the problems in this chapter using algebra is much easier, so I renamed the chapter as Algebra chapter using comparison and substitution, which is quite similar to the concepts taught in if you have this book, is quite similar concept taught in this book as well, but I just use algebra to solve them. Let's go through some basics on algebra. To use algebra, we want to solve the problems that we are given by writing down equations. Okay, so what do I mean by equations? Equations are simply like a plus b equals to 3. This is an equation. If a equals to 1, b equals to 2. So you have 1 plus 2, so equals to 3. This is an equation. Okay? Equation simply means that the left hand side equals the right hand side. Okay, so a problem can be expressed in algebra using equations. Okay. Next, if there are two variables, okay, we need at least two equations. That's what this means. So the number of equations must be greater or equals to the number of variables for you to solve the variables. So for example, if you have if you're asked to find the price of an apple, which is denoted by A here, okay, and you're also asked to find the price of an orange, which is denoted by O. So if you're just given that a price, if you buy one apple and 2 oranges, okay, the price is $5. Okay, you will not be able to solve this, right? Because there are definite value of this, because there can be multiple values of A and multiple values of O. Whereas on the other hand, if you're given two equations, let's say the price of an apple plus price of an orange, okay, is 3. So in this case, you should be able to solve the equation. Okay, solve for the variables. So for example, here will be an apple is equals to 3 minus O, and then you can substitute into this equation 1, this equation 2. So you're able to substitute A inside here. So you have 3 minus O plus 2O equals to 5. So you have 3 plus O equals to 5, and O will be equals to 5 minus 3, and then you have O equals to 2. And then the price of apple is just nothing but 3 minus O, which is equals to 3 minus 2, which is 1. So the price of apple is $1 and the price of orange is $2. So you're able to solve the equation if you have you're able to solve the problem if you have two equations in this case. Okay. Next, the third point is let a character represent a variable. Okay, what do I mean by let a character represent a variable? So in the earlier example, you have A represent the price of an apple. Okay, and you have O represent the price of orange. Right, so you let characters represent a variable. Okay, and then you would the fourth point is units can be used for checking. What do I mean by units can be used for checking? Okay, so units are some like what are units? Okay, units are dollars, okay, kilometers, hours, okay, liters, then you have centimeters, for example. Okay, all these are units, right? So if an example, let's say the equation, right? For example, just now the example of apple plus the price of 2 oranges equals to $5. Okay, so the unit here actually is the dollar. Okay, the A is actually a price, right? So it's dollar, and down here is also a price, right? Dollar. So something that is a dollar plus dollar will give you dollar, so it works. Okay, whereas if you write out an equation that is a unit, for example, plus 20 equals to $5. Let's say here it's not a dollar form. Let's say here's the number of apples. Okay, not the price of an apple. Okay, or then what happened is that you will not be matching, right? Because here is the number. Let's say whatever number you have, X. Okay, and then now here's a dollar plus dollar. You can't have dollar plus a number and give you a dollar. Just like you cannot have 5 apples, okay, plus $5 plus $5 give you $5. Doesn't make sense, right? So units can be used for checking. So for example, if you have the answer is in speed, kilometers per hour. Okay, so in this example you cannot have let's say 5 km plus 5 kmh. Okay, this doesn't match because the units doesn't match, so your equation is wrong. Okay, whereas let's say you have speed plus speed, so let's say you have 10 kmh plus 12 kmh. That you can, because the answer is what, 22 kmh. So it works, right? So it works. Okay, again, another example is that let's erase this first. So what I mean by unit, so for example, you cannot have let's say I ask you to find speed, right? You cannot have, if you have 5 kilometers divide by 2 hours, okay, that will give you km divided by h, so you will get speed, right? You get speed. That makes sense, right? Which is 2.5 kmh. Whereas if you come out with something like 5 kilometers divided by let's say 2 kmh, it doesn't work, because you can see that actually it becomes km divided by kmh, alright? So the h becomes top, right? So your answer, this km will cancel each other, and then you have hours instead, right? This gives you the time, not, okay? Just give you the time, not the speed or whatever you want. So in terms of units, okay, is an advanced checking principle. We will cover in the later examples as well. It will allow you to check whether your equation is written correctly or not. Alright. Next, substitute value into another equation to check. Okay, this is basically how you can do checking. Okay, so let's erase this. So if you have an equation here, for example, y plus x equals to 40. Okay, that's equation 1, and then you have x equals to 3y, that's equation 2. And then you substitute, right? Substitute 2 into 1, right? Because you know x, right? So you substitute x inside here. So you will have y plus 3y equals to 40, and then you will have 4y equals to 40, and y equals to 10. Alright, so after that, you substitute the value of 10 inside here. You have x equals to 3 times 10, so x equals to 30. Right? So you use equation 2, isn't it, to find out the value of x. So you can use back equation 1 here to check whether it's correct or not. So you have y equals to 10, so you have 10, x is 30, down here, x is 30, so plus 30 will give you 40. So you know that you have done it correctly, right? Okay, that's called substitution to check. Now let's revise basic algebra. X here, the problem is x cos 2 times of y. So how do you write this equation? Basically, and then you have 5 of x plus and 10 of y cos $200. Okay, so find x and y. So the solution, you have this here, okay, this equation here basically comes out with this, right? You have x cos 2 times of y, so x cos 2 times of y, that's your equation 1. Then you have 5 of x plus 10 of y equals to $200. Okay, that's your equation 2. Okay, so later that since you know x is equals to 2y in equation 1, you substitute x inside here. So you have 5 times 2y plus 10y equals $200. So 5 times 2 essentially will give you 5 times 2 will give you 10 plus 10 give you 200. So don't need anybody, simple mathematics, 20y equals $200, and then y equals to $200 divided by 20, and then you have y equals $10, right? And then you just need to substitute this y, right, into this equation. Then you have 2 times $10, so x is $20. Alright. Then how do you check? So you can use equation 2, right? 5x plus 10y, is it equals to what? So down here you have 5 times 20 plus 10 times 10, right? So this one gives you 100, this gives you 100, so it gives you 200. So it matches equation 2, so you're correct, right? In this problem, 5 tables and 18 chairs cost $594. The cost of 1 table is the same as the cost of 3 chairs. Find the cost of a table and a chair. Okay, this is a very basic and simple problem to solve using algebra. Perhaps you can pause this video and think how to write these equations. There are two equations here. Alright. Okay, now let us see what is the answer. So we let x be tables and y equals to chairs. Okay, you can use other alphabets, it's up to you. So they said that 5 tables and 18 chairs cost $584. That's for equation 1. Equation 2 is that the price of one table, which is x, equals to the cost of 3 chairs, which is equation 2. So you substitute 2, okay, you substitute 2, this x into 1, okay, so you have 5 times 3y, because your x here is 3y plus 18y equals to 584, right? Then you have 5 times 3 is 15y plus 18y equals to 584. That's 33y equals 594, and then y equals $18. Got it? Alright. So it's just simply 594 divided by 33 gives you 18. Alright. Then you substitute y into equation 2 to find x. Okay, equation 2, which is this one, right? So you would have x equals to 3 times of $18, which is $54, right? Simple. Okay, now example 2 about money, using money. Again, 4 basketballs and 6 footballs cost $460. A basketball is $15 more expensive than a football. How much is each basketball? How much is each football? Okay, again, you can pause the video and try to solve it yourself. It's not a very difficult problem. If you can solve it, it'll be great. Okay, now let's proceed. The solution: let x be the basketball, and actually the price of a basketball, and y to be the price of a football. So you have equation 1, 4 basketballs. Now here they mentioned, right, 4 basketballs, and you have 6 footballs cost $460, right? So you have this equation. Okay, because you multiply the number with the price. Okay, because the price of a basketball, sorry, okay, here's price, okay, price, so you have 460, right? Then the other one is the price of a basketball is $15 more expensive than a football. So football, you need to have $15 more to be equals to the price of a basketball, isn't it? Because more expensive, because the price of a basketball is more expensive. Okay, so substitute 2 into 1, then you have because down here is actually 4x plus 6y, right? So x is just a matter of this equation here. So we have 4y plus 15 plus 6y equals 460, and then you have 4y. So basically this type of bracket, right? When you write brackets, what do you mean, right? It means that this 4 is multiplied here and multiplied to this 15. So you get 4y plus 60, okay? Equals to 6y equals to 460. And that's then y equals $400 and y equals $40, right? And substitute y into equation 2. Then you have x equals to $40 plus $15. So x equals to $55, right? You can check, yes, again, you can check. Okay, so what I'm saying here again is the units, right? Because you can see that the units here are dollars. So dollars plus dollar is possible. You cannot have dollar plus, say, kilometers. It doesn't make sense. Okay, so it must be something. So if the two units multiply by another unit, what do you get? So let's say $1 multiplied by $1. It's not possible as well because you know, do we have a dollar squared? Okay, because that will be this. So a dollars can only be multiplied by something like a unit, right? So for example, the number of basketballs. You can have dollar multiplied by dollar as well, and you cannot have so because multiplication means the units will double. With division means the units will cancel. So for example, if you have dollar divided by dollar, let's say $5 divided by $2, you will have 250. There will be no more dollar sign in front. Okay, so for example, I'm told that an orange costs $10 and I have 5 oranges. So what's the price of one orange? So if $10 divided by 5, you have 2. So price of one orange is 2 because there's no unit here, so you retain the unit. Got it? Okay. Now let's go to example 3. 5 kg of sugar and 6 kg of rice costs $84.50. 2 kg of sugar and 3 kg of rice costs $41. How much is 1 kg of sugar and how much is 1 kg of rice? Again, you can pause the video to write the equations. Okay, so let's proceed. Solution. So let X be the price of sugar per kg because you want to find out what is the price of 1 kg, so it's per kg, right? And let Y be the price of rice per kg. So you have 5 kg of rice, right? You have 5 kg of rice here and 6 kg of 5 kg of sugar and 6 kg of rice costs $84.50. So that's equation 1, right? So you have 5 kg of 5. Okay, again down here the unit, right? You have 5. You have a unit here which is 5 kg, and down here is $5 per kg because price, right? X is price, so price is price per kg, which is written as dollar per kg. So for example, if it's $1 per kg, then it's like this, right? So you can see the kg cancel off each other, so in the end you have dollar, okay, which matches this here because there's no kg here, right? It's only dollars. Got it? Same with 6y here. 6y is also 6 times y, which is in dollars per kg. Okay, so down here is 6 kg, so you cancel kg, you get $90 because 6 kg, right? 6 kg of rice. So equation makes sense. Alright, so let's erase my ink. Okay, then you have 2x plus 3y equals to $41 in the next statement, right? Tell you 2 kg of sugar and 3 kg of rice gives you $41, isn't it? Okay, simple. And then you just, okay, how you solve this problem, right? Because it's not like the ideal problem so easy to apply, but you can see down here, you can see here that you have 3 here, which is which is half of 6. So if you multiply equation 2 by 2, okay, what you will get is 4. So you multiply everything by 2. So 1 becomes 4, 6 become 3 becomes 6, 41 becomes 82, right? Then after that, you can have equation 1 minus equation 3. Okay, equation 1. So you have equation 1, which is 5x plus 6y equals to $84.50, and then you have 4x plus 6y to $82. So you want to eliminate the y's. Okay, you want to eliminate the y's. So to do this, you have minus, right? This equation minus this equation. Okay, so you perform a minus. So this one, what you have left? 5x minus 4x, you have x left. 6x minus 6y, because the whole thing is minus. You don't minus only the 4x. Alright, so because minus times plus is minus, so here is 0 plus here we have 250. So x is 250, right? Okay, then you have 3y equals to $41 minus 2x. Okay, so basically it's just solving this part here, isn't it? This taking the equation 2. Okay, you just take equation 2, okay, and rewrite it, right? Rewrite it. Then you have y equals to 41 minus 2x divided by 3, and then you substitute x inside, and then you solve it. You get y equals to $12. Okay, got it? So now let's go to example 4. If 10 rabbits can be exchanged for 2 goats, 9 goats can be exchanged for 3 cows, and 9 cows be exchanged for 2 horses. How many rabbits can 5 horses be exchanged for? Okay, this question sounds a bit complicated in the beginning, but actually it's quite simple. Okay, pause your the video and then you try to form the equations yourself. Okay, in this case it's better to use not just x, y, z, but maybe g to stand for goats and so on. Alright, now let's see the solution. Okay, let R be rabbits, G for goats, C for cows, and H for horses. Okay, so the first equation you have here, okay, 10 rabbits, right, can be exchanged for 2 goats. So you have 10 rabbits can be exchanged for equals to 2 goats. Then you have 9 goats can be exchanged for 3 cows. So you guessed it, 9 goats can be exchanged for 3 cows, and you have 8 cows. 8 cows can be exchanged for 2 horses. So you have 8 cows can be exchanged for 2 horses. So there are 3 equations. Okay, what can 5 horses be? How many rabbits can 5 horses be exchanged for, right? Okay, down here you have 4 variables and 3 equations. Okay, I mentioned that you need the 4 equations to solve 4 variables, right? But in this case, they are only interested in 2 variables here, which is they are interested in relative, right? So how many rabbits can 5 horses be exchanged for? So they are only interested in rabbits here and also horses, right? So 3 equations more than enough. So you have 5 goats equals to 3 rabbits from equation 1, right? So you have because you have 2g equals to 10r, so a g equals to 5r. That's it. Okay, then sub this into equation 2. You have because you know goats now, right? So you have you know goats now, so you have 5 r's. Okay, so you take the r's, so you know that there are, you need 3 cows. Okay, you have 3 cows equals to 45 r's. So the proportion, you are talking about relative, so you have 1 cow, so if you have 1 here, so basically it will be 3 equals to 45 r, right? Then 1 rabbit will be 3 over 45. Okay, if there's 1 cow only, right? Then you have so 1 cow equals to 15 rabbits, right? You need 15 rabbits to get 1 cow, basically, what this equation tells you. So sub this into equation 3, you have 2 horses equal 8 cows. So you know cows got how many rabbits? Okay, so what happened is that you have so you just bring this 2 across, become division, right? And then this cancel. Here's 4, 1. So what do you get? 60, right? So you have 60, 1 horse, 60 R. So you want to know how many rabbits can high horses be exchanged for. Sorry, it's a bit messy, so let's clear this out. Okay, so you have 5 horses now, right? So just times 5 equals 300 R. Okay, so 5 horses equals 300 R. Okay, so basically the proportion, when you have 5 horses, then this H equals to 1. So you need 300 rabbits. Right? 300 rabbits. Okay. Okay. Now let's look at example 5 regarding speed. It takes Mark a total of 25 minutes to run a distance of 1000 meters and then walk 2000 meters. It also takes him 25 minutes to run a distance of 4000 meters and then walk 500 meters. How fast can Mark run? Okay. Take a minute to think about this problem. You can pause the video. If you want, you can write the equation. Okay. If not, let's continue. Alright. Firstly, you can see that over here you're asking for speed, right? So how is speed usually expressed? Okay. Speed is usually expressed as kilometers per hour or miles per hour, or in this case it will be meters per minute. Okay, because they give you meters and then they give you minutes. Alright, so you can express in meters per minute. Okay, that's speed, right? It's always over time. Okay, so in this case, let R denotes Mark's running speed, okay, which is meters per minute. Alright, and X will be equals to inverse, right? So X here is the inverse of speed. Why we do that, right? So I will explain to you later. W is actually the speed of Mark's walking, and Y denotes 1 over W, which is the inverse. Okay, because basically, as I mentioned, right, if you 1 divided by W equals to, if you take a unit, right, it's minimum minutes divided by meters. So this thing goes on top, so it becomes meters per minute. Okay, sorry. Okay, maybe let me explain here, right? So basically you have Y goes to 1 over W. So 1 over W is actually the speed. So speed, the unit for speed is what? Meters per minute, right? So the units for this will be minutes per meter because inverse. Okay, so the minutes go up and the meters still remain below, right? So it's so why is minutes per meter? Why do we need to do that? Because you can see, okay, the first equation is 1000 meters. Okay, when you divide by the speed, you get the distance, right? Because you get the time, because you want 25 minutes here. Okay, minutes. So down here the unit is, right, meters per minute. Okay, so by dividing distance and the speed, okay, you will have m will cancel and the minutes will go on top. So you will have minutes here, right? Plus down here is 2000 divided by W, and again here is meters, and down here will be meters per minute. So the minutes will cancel and then this minute will go up. So you have minutes plus minute. So it's time plus time equals 25 minutes, which is time. Okay, so this equation makes sense, right? Okay, but we add x and y denote 1 over r and 1 over w respectively, because we want, it's very difficult for you to look at equations that's division, isn't it? So it's easier if you just substitute 1 over r with x, right, with x, right, and then w is 1 over w, right? So you have a simple, I mean, it's visually simple for you, right? Then the other one is just the same, right? 4000 divided by r gives you the time taken to run 4000 meters, right? Because we have distance divided by speed give you time, right? So basically 5000, then 500 divided by the walking speed gives you 25 minutes. So again, we just substitute x here and then y here with these equations, right? So it's easier. Okay, then next, multiply equation 2 by 4. Multiply equation 2 by 4. Okay, so let me erase this because it's a bit confusing now. Okay, so multiply equation 2 by 4. Because why we multiply by 4 is because we want to eliminate y. Okay, so if we multiply this by 4, okay, you have to multiply this by 4, so it gives you 16,000 x. Multiply this by 4, give you 2000 y, and multiply this by 4, give you 100. Okay, that's what you get, right? Then after that, you have equation 3 minus equation 1. So what you do is equation 3, okay, that's 2000 y equals to 100. This basically means that if I run 16,000 meters and walk 2000 meters, it take 100 minutes. Okay, so basically what you have here, and then this equation 3 and equation 1 is 1000 x plus 2000 y equals 25, right? So you have 3 and you have 1 and minus. So what happens is this. So 16,000 minus 1000, you have 15,000 x. 2000 minus 2000, you get 0. And 100 minus 25, you get 75. Okay, so basically you have 15,000 x. Okay, x equals to 75. Correct? Okay, and then you have x equals to 75 divided by 15,000, but this is minutes per meters, remember? So you want to get speed, right? So substitute x inside, right? It's just the inverse. So what happens is that you have r. So basically, so you have x equals to 1 over r. So r equals to 1 over x, right? So it goes 1 over 200. So it's just 200. Okay, so the speed of this, and the unit is minutes, is meters per minute. Okay, because speed is meters per minute. So basically, Mark can run 200 meters in 1 minute. Alright, hopefully you understand. If you have any questions, you can leave in the comments below. If you enjoyed this tutorial, please like and share the video, because the more likes I have, and you can subscribe to the channel as well, because the more likes I have, you'll motivate me to produce more of this sort of videos. And appreciate if you can subscribe to the channel, to my channel, so that if there's the next video coming up, you'll be notified. Alright, thank you.